Consider a particle that moves along a line with a position function x of t equal 30 plus 16t minus 2t squared. This function tells us how the position of the particle changes with time. We can see this change on a position time graph as shown at the top. The graph shows the value of x at any time. For example, when t equals 0, the particle is at x equals 30. When t equals 4, the particle reaches its highest position at x equals 62. The green dots at the bottom show the particle's position every 0.1 second. A turning point is when the position changes from increasing to decreasing, or vice versa. For this function, there is a turning point at t equals 4, where the particle's velocity is 0 and its direction reverses. The velocity is the rate of change of the position with respect to time. We can find the velocity function by taking the derivative of the position function. The acceleration is the rate of change of the velocity with respect to time. We can find the acceleration function by taking the derivative of the velocity function. For this function, the acceleration is constant and negative, which means that the particle is slowing down when moving to the right and speeding up when moving to the left. The acceleration function is a of t equal minus 4, and the velocity function is v of t equal 16 minus 4t. We can also find the velocity of the particle at a particular moment by finding the slope of the tangent line to the position time graph at that point. For instance, at t equals 0, if we draw a tangent line and calculate its slope, which is the change in position over the change in time, we find it to be 16, indicating the velocity at t equals 0. Similarly, at t equals 4, the tangent line is horizontal, reflecting that there is no change in the vertical position over time. Hence, the slope is 0. This means the velocity at t equals 4 is 0, which also corresponds to the turning point of the particle's motion. At this instant, the particle ceases its movement to the right and begins moving to the left. This method allows us to visualize the particle's velocity at any given time and understand the changes in its motion.